Like I had this debate with someone about models. They were saying the models are bullshit. And I said, well, that's kind of a strong word. The models are bullshit.
Yeah.
That's not really how it works. I said the models were based on the data they knew at the time, and they keep revising the models. That's what a model is. A model is based on, it's as accurate as the information that you have. Well, then it's bullshit. They're very simplistic about this.
Yeah.
I said, that just means you don't understand what a model is. And of course, that doesn't go over well.
Welcome to the Deep Chat. This segment was originally recorded on April 15th, 2020.
But that's an interesting part about all this, is that the model was inaccurate because we didn't have the right information, and we're starting to get more of that information, and the numbers are driving downward. So the latest estimates are 60,000 deaths, which is on par with a flu season, the number of deaths from the flu. Now, again, that is the result of a lot of the stuff put in place across the globe.
But that's only so far, though, right?
No, that's the projections based on what we know about the disease, and the current projections is 60,000. Even the
I don't know that number. I'm not doubting it, but something's not reconciling for me, because we are not yet at the peak in LA. I'm watching LA specifically very closely. We might peak in mid-May. That means that finally the second derivative is almost below 1 now. So we've passed the point of inflection. We're starting to curve, but they're at least 68% of the deaths are ahead of us.
Yeah, except we're only losing in LA roughly 50 people a day. So
no, that's not right. Hold on, let me pull it up.
We've only lost 800 total in LA.
360 in LA.
Yeah. Over the
losing about. Oh, I'm sorry, you're right. Yeah, we lost 40 since yesterday.
And I'm not saying that's a good thing, but it's certainly not something that is as alarming. And then the numbers are not going to meet the upper projections. See, initially I read that the projections were 60,000 to 2 million. I mean, it was a huge number in the early days of the model, and then they kept revising it and narrowing it. And at some point, they narrowed it down to 200,000, and then they narrowed it back down to 60,000.
Well, the good model should also capture uncertainty. So it should express what it knows from the data it has so far, but in a way that reflects sampling error and not seeing enough and future volatility and all these sorts of things.
Yeah, and I don't know. Yeah, I don't know how to do that. That's why I think they gave the range, right? They don't want to outright say this is how many it's going to be, because they know they're going to be attacked one way or another, either by the left or the right. Somebody's going to attack them over it. And indeed, that did happen. So now people are, it's amazing to me. It really is. It's such a weird time because it's so polarized. There's the people who want to believe that it was never a big deal. And they're going to say, look, there's only, 40,000 people died from it. It wasn't a big deal. But they're going to ignore the fact that we put all these precautions in place to bend the curve. And then on the left, they're going to say, well, it would have killed 2 million people if we didn't bend the curve, which is just as inaccurate as what the right is saying, which is, we didn't need to put all these precautions in place. The precautions are what saved us from having more deaths. But on the other side, we probably wouldn't have had 2 million deaths.
But we have counterfactuals. We can look at Italy, for example.
Yeah, and then how many people died there?
I don't know the numbers, but that's painted as one of the worst. So for like the conspiracy theorists saying, oh, this isn't that big of a deal, you can say, and we wouldn't have had that many deaths, we didn't really need to flatten the curve. You could point at that country and say, well, what about there?
Well, you know what the answer to that is? And this is where it gets into human psychology. The answer to that is always going to be, well, they'll pick some tiny little aspect of Italy. Well, they have an older population. And then they write it all off. Or their medical system isn't as good as ours. And then they write it all off.
Well, let's do older population, because there's some truth in that. But, I mean, do you really have so little regard for the elderly? I mean, what kind of statement is that? That, by definition, makes it a big deal.
I know. And whichever way you slice this problem, you're losing, no matter which way you slice this problem, on the left, on the right, because at the heart of it, the model is as accurate as the data you have. And There's so many confounding variables.
Yeah, so we can also, there's two categories in my mind. There's the quality of the data, but we can also attack the model's mechanism if we want to.
Well, tell me about that. What does that mean, attack the model's mechanism?
Most people use this SIR model to describe the progression here. That's what a lot of the numbers derive from, even though people have little variants of it and stuff they're doing with it. It starts from assumptions that are just a formula and says this is how these three variables evolve with respect to one another. And if those formulas describe nature, then they're good. In the same way like Maxwell's equations describe electricity and magnetism. Einstein's relativity describes gravity, and so do Newtonian mechanics. Those functions, those like pure physicist functions, they really work. We know the source code for the universe at the physics level. At this epidemiology level, there's a lot of hand waving because ultimately involves, millions of Turing machines running around on the planet making decisions in different ways. You can't model all that. You have to make assumptions somewhere. And those assumptions implicitly weaken your model.
Well, that's my word for a confounding variable, right? Those assumptions, right? There's the assumptions made in the model. That's really what I'm talking about. It seems to me that that's why the model got narrowed, and it was the assumptions were narrowed down, or there were less assumptions.
The other way, and maybe this is a fine point that only I would care about, but the model could be good while the data is bad. Like earlier you were saying, the denominator could be off from what we think. If I were an epidemiologist, and I haven't gotten this deep into literature, so I don't know if this happens, but I would have a mechanism for accounting for that. I would say, we know this many people won't report, or we stratify it by age group and we extrapolate. If that denominator was important to me, I would take on the burden of complexity in my model in order to inference it, thanks to some confounding factors, right? Like maybe I knew beforehand the likelihood that age groups submit to hospitals, and I could use that in some way to infer how many are staying home. And then, depends on the confounding factors are actually good things, because the degree to which two variables share mutual information means if I learn about one, I might learn about the other. But garbage in, garbage out. If the data is not good, the model won't make a good prediction.
Right. So take, for instance, if you had one variable that was the health assumptions, like the generalized health of a nation, and I'm assuming that probably is a portion of their model, right?
I would hope so.
Right. So if that's wrong, that could throw off everything. Like, how do you quantify the health of a nation in relation to data that you already have? Like, you would need to compare it to Italy, and Italy's health is what compared to the health of the United States? So you'd have to go to literature or prior studies and find out what that looks like, which is probably difficult. And that's just one variable.
Yeah. Well, to play the devil's advocate against that, a technique you can use is like a sensitivity analysis. So you say, okay, we have this variable for the health of the nation. It's a scale of 1 to 10. And right away, you don't have to be a seasoned skeptic to be like, what is this number? How did you come up with it? But, and cast a lot of doubt on it, because it's the single number that sums up, 300 something million people with one number. But the sensitivity analysis is where you plug it in and you say, well, okay, maybe it's off by this much, or it's in this range. If we do a bunch of random simulations and we try different values that are close but not quite to what we estimated, it only changes the model's outcome every so often. Think of it this way. What is the impact of a certain college on a person's professional earning long term? I mean, surely it's there in like the networking sort of way, but on some level, an education's an education. If you want to know how sensitive it is to the particular school, you could do an analysis where you say, well, if I had taken one person out of a sample and put in the closest equivalent, but they went to a different school, how often does that change the total value I'm calculating? And even if, the salaries are lower or whatever, if the aggregate metrics don't have much impact, you can say we're not sensitive to this value. So even though it's imprecise, it's not hurting us.
So if you were to guess, what do you think is the major source of problem with the current models that they're using for projections?
That we have never had what they call the Goodhearts law has never kicked in this much. Goodhearts law is where you predict something and the act of predicting it causes it to change. In this case, it's predicting like, we're going to have so many deaths. That's an alarming number. people get the message they need to store and stay indoors, and they change their behavior. That behavioral change is not only probably not in the model, although I'm sure people are coming up with ways to do it, but anything they're doing is just math for math's sake to some degree. This is unprecedented. The closest thing we have, I mean, SARS and MERS and all that, but there's never been this global sort of a shutdown like this. We don't know how good people are at it and how effective it'll be.
I find this to be a fascinating time period for collecting data about the Earth and how this is going to teach us so much about the human impact. I think it's probably been discussed elsewhere, but I find that fascinating because we've effectively shut down most of industry. And obviously in LA, our air has improved, and we've seen pictures all over India and China of the air improving. We currently have a customer who collects through satellites, they collect data about weather. And they're really chomping at the bit to get certain data from us because I suspect, they haven't said it, but I suspect that they really want to collect more data. So they want more passes. That's when you talk to a satellite, they want more passes from us so that they can get more data. And that's probably because they recognize the unprecedented nature of what's going on right now. This is not, you're probably never going to get this again in our lifetimes, where the entire globe effectively came to a standstill. And how does that affect nature? How does it affect the weather patterns? It's going to be an amazing, 2-month period of data that they're always going to reference.
Yeah, I want to know what it's going to look like to archaeologists of the future.
Well, there's geological time. So that's something, one of the things I used to do was to monitor using sensors, all sorts of geological things like the slope displacement in a strip mine or displacement of Earth, trying to look for trends to see if it's going to collapse into a cavern that holds the U.S. oil reserves. It was always interesting to me that day in and day out, there was almost no change. So it's really about years and looking at the trend over years than it is the day. So my point is, geological time is hard for us to comprehend because as humans, we see change and we see it. That's our primary input. We identify with quick change. But for something like this is basically a blip on the radar for the Earth. That's my guess. In terms of the sediment, things like that, this will go almost unnoticed 100 years from now in terms of the archaeological aspect of it, just because there's not enough time for this. If this happened for 4 years, yeah,
that's a good point. Even 4, it is a blip. I hadn't thought of it that way.
Yeah, do you ever see those diagrams that show how long humans have been alive compared to the age of the universe or age of the planet? Even
where it's about to, on the year scale, we're about to pop the champagne for New Year's Eve.
Right? Yeah, it's like nothing. It's nothing.